Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's get started on lesson 4.1.2. This is called Seeing Growth in Different Representations. So what we want to do over the next couple of lessons is we want to look at different representations and see how you see the growth occurring in the table. What are you looking for in the table to see the growth rate? What are you looking for in the patterns to see the growth rate? Where in the rule do you see the growth rate, and how do you see it showing up on a graph? We're not going to get to all of these today, but we will be building on this concept of growth through various representations, starting with geometric patterns today, and then we're going to transfer that information into tables tomorrow and create rules for these situations, which I believe we'll be doing that today, and eventually we'll get to those graphs as well, which could be in tomorrow's lesson as well. So let's go ahead and read through this. Some good information here. Seeing growth in different representations. In lesson 4.1.1, you looked at 4 different ways of representing patterns and began to find connections between them. Throughout this chapter, you will explore connections between and find efficient ways to move from one type of representation to another. Today, you will look for specific connections between the geometric patterns, which would be like the algebra tiles, and equations, which are, it's another term for rule. As you work, keep these questions in mind. How can you see growth in the rule? How do you know your rule is correct? What does the representation tell you, and what are the connections between these representations? So we'll refer back to this diagram multiple times. Remember, when you have some kind of a word problem that involves 2 variables and one affects the other, you have an independent and a dependent variable, and the problem will take the information from the problem and create a rule for it, maybe organize the data in a table, and then show a graphic representation of what that problem is about. So we're starting with geometric patterns, those algebra tiles. Eventually, we're going to leave this behind, and we're going to get into some real-world problems that can be expressed as a rule, that can be put into a table, and can be graphed. And once you start seeing how the growth rate shows up in each one of these representations, then it makes it a lot easier to understand what type of a problem you're going to be solving and use the tools that we've learned to solve those problems. All right, so you eventually are going to get a hold of a, I guess I shouldn't say eventually, I have put a PDF page onto the classroom, and you can access it. If you have a printer, you can print it off. If you don't have a printer and you just want to draw these figures into your journals, you can do that as well. Just be very, very careful. Use rulers. Make sure that you use the squares on your graph paper so that you get everything of equal size and properly proportioned. But if you do have access to a printer, I highly recommend you figure out a way to get this printed off, because it'll make your job a lot easier. All right, so what is it we are going to be doing with these tile patterns? First thing we're going to be doing is we're going to be looking at these patterns to see if we can identify a constant growth rate or some sort of a pattern with the growth rate. We saw yesterday's lesson that each one of those tile patterns that we had exponential growth. Today, things are going to be a lot easier. We're going to have linear growth, so there will be a constant growth rate. We won't have to worry about finding squares and identifying the different parts. Now, we might still want to identify the different parts, but it's going to be, I think, a little bit easier to find or create the rule for this situation. So first off, we're going to look for a pattern of growth. Then we're going to use that pattern of growth to predict the number of tiles that would be in the 0 figure and the 4th figure. The reason why we want to find that 0 figure is because you may recall from earlier in the chapter when we were playing the silent board game, how when x is equal to 0, the number that corresponds, the number of tiles there corresponds to a y value or an output when x is equal to 0. And that was an important number for our rule. So whenever we see these tile patterns, we always want to figure out what the growth rate is, and that is how much does it increase every single time, and then work our way backward to figure 0. And when you put those two together, that's going to help us find the rule. Okay? So let's take a look at this tile pattern here. I like to start off by identifying how many tiles there are in each figure. So this one has 1, 2, 3, 4, 5, 6. So I'm going to write a number 6 here. This one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to put the 10 here, and then this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So what is the first thing that you are noticing about this pattern in terms of, say, pattern of growth? Well, hopefully you're noticing that every figure number has 4 more tiles than the previous figure number. So that piece of information is what we refer to as growth. How much does it go up each time? And I could put a little plus sign because you could have tile figures where the actual number of tiles goes down instead of going up. So it's increasing by 4, so the growth is positive 4. Okay? So if that's the case, what would you expect the 0 figure? How many tiles would you expect to be in the 0 figure, and how many tiles would you expect to have in figure number 4? This is where using our this PDF form, the resource page 4.1.2 will come in handy. And let me go ahead and show you what that looks like. Here is the PDF form. Okay. Oh, did I not want to show all this? Oh, okay. Well, you can see it already. So the growth is positive 4, right? And so the pattern, if we're looking for patterns, I would say, all right, let's color code this. Do I want to do it with a highlighter? Yes, sure, I'll do it with a highlighter. First off, I'm noticing going from here to here, you're adding a tile onto each one of those. Are they called arms? Is this an arm and that's a leg? I don't know what you call them. But every time you add 2 in a row on the right-hand side, and you add another 2, 1 on each one of those arms. So notice how here's what we had in the previous one, and then we add another 1 to the leg, 1 to the arm, and another row there, and then the next one, so on and so forth. So being able to see where things are being added on is important, as well as being able to see how many have been added on. So if I were to work in going backwards to the figure 0, then we would take away this guy, we would take away those 2, and we would take away that, and that's why I have 2 tiles shown in this particular figure. Okay, so as we saw on the previous page, this one had 6, this one had 10, this one had 14. So how many do we expect this one to have? We expect this one to have 18, right? Because we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, but we're going to add 1 here, you're going to add another 1 here, and then you're going to add 2 there. So that's how we get our 18. So to describe the pattern, we would say it adds 2 to the body, right? If we consider this the body, and add 1 on each arm. So go ahead, copy down these. Do you notice how me doing it freehand, it's a little bit sloppy? I expect it's probably going to be a little sloppy for you. But just try and make it look as neat as you possibly can. That's fine. Okay? So from this, I have figured out that the rule appears to be y equals 4x plus 2. Because every figure number, if you take this number and multiply it times 4, you get 4, then you add 2, you get 6. You take this figure number, you add, or you multiply it times 4, you get 8, plus 2 is 10. Take this figure number, multiply it times 4, you get 12, plus 2 is 14. Sorry, I had a little whatever. Okay. And then figure 4, that means it would have to have 18, since 4 times 4 is 16, plus 2 is 18. And figure 0, one of the more important figures, our starting spot, when x was equal to 0, it doesn't matter what number you multiply times x. In this case, 4 times 0 will be 0. So the number 2 ends up being that very important piece of data. Okay, so once we know that the rule is correct, now we can apply that to the 100th figure. So how many will be in the 100th figure? 4 times 100 plus 2 is 402. So let's go back and answer these questions. So we've just sketched the figure 4 and the figure 0. We decided there were 2 in the figure 0 and there would be 18 in the figure 4. So with that, how is the pattern growing? We can say that just what I had here, a tile is added to each arm and 2 tiles are added to the body. So what would the 100th figure look like? How many tiles would be in the 100th figure? Well, the 100th figure, let's go back and look at this. If this tail right here is the same number as the figure number, right? 3 in that tail, figure number is 3. And then the arm up here also has 3, just like the figure number. And we would think that the 100th figure would probably have 100 on the tail and 100 in the arm. And then what's the relationship between this body here and our figure number? It kind of looks like, what does that look like? Are we taking this number and doubling it and then adding 2? Let's see if that what happens here. That's a 2 and that's a 2. And then this would be 2 times the figure number plus another 2. So we can break this up into a couple of different parts. You got the arms, which you've got 2 arms, and each one has the same number of tiles as the figure number, so we'll double that. So this has 2, right? That's 2 times 1. This has 4, which is 2 times 2, and this has a total of 6, which is 3 times 2. And then the body has, what did we say? You double that and add 2, you double this and add 2, so that would be 2x plus 2. So now if we combine like terms, put it all together, that's where you get your 4x's. Oops, I should say y is equal to, because it is a 2-variable rule. Y is equal to 4x's plus the 2 that's right here, right? For that figure 0. So with that being the case, how would we describe the 100th figure? Well, each arm is going to have 100 tiles in it, right? You'll have 2 arms with 100 tiles in each. That would be 2 times 100 for 200 tiles. Oh no, the body is going to have 2 times 100 plus an additional 2 tiles. So here you got 100, 200, 300, 400 plus those additional 2 tiles gives us 402 tiles for the 100th figure. And if we use our logic, we broke down for each one of those parts, right? The body and then the arms, and we compare that to what we're saying with the rule that we created. 4 times 100 is 400, and 400 plus 2 is 402 total tiles. Oops. Very, very messy. Much better. All right. Let me pause for just a moment. All right, so a piece of information I would like for you to write down. This is essential, okay? So x is always going to be the figure number, and y is always going to be the total number of tiles. So just like I did here, if you can break this figure and find out where the growth happens within each specific part, and how we can relate that to the figure number being x, then it's going to make life a lot easier for figuring out the rule. Now, let's come back to one last thing. Remember when we said that the growth rate here was 4? Actually, let me change that to green. No, I'll do it in yellow. Notice that number right there is what's being multiplied times x. And what is the 0 figure number was 2. Notice that number right here in the rule. You are now seeing the shortcut of how you determine the rule. What's the growth rate? That's the number that gets multiplied times x. What was the starting amount, or the figure 0? 2 tiles. That's the number that's being added on at the end. So let's look to see if this ends up being a trend. Whatever the growth rate is the number being multiplied times x, and whatever the figure 0 is that number being added on at the end. This could make your job, your life, much easier for solving these problems. So here's your task. You are going to continue this process for tile pattern 2, 3, and 4. And I know there's a bunch of wordy directions over here, But just follow the same process that I went through. Count the number of tiles, right? That is your, how much does it grow to go from this one to this one to this one? That's your growth rate. How do you see the pattern growing? Write a little statement in the right margin here. I will tell you this, none of this is in the right margin of that resource page that you might be printing off. Just write it in. Just write in these words and record the information, or record it into your journal if that's where you're putting this information. So once you see the pattern of growth, and once you see where the zero figure is, then put those two together to create your rule, and then use that to determine the number of tiles in the 100th figure. Okay, so I'm going to go ahead and pause. I'm going to let you work out your tile patterns for 2, 3, and 4, and then when we come back, I will share with you what the correct answers are. So take your time on this. This is really good information to help you when we get to the higher levels of problem solving that we're going to get into in some later chapters. All right, let's take a look and see how we did on this. Looking at tile pattern 2, these crosses here, first thing I do is I count the number of tiles for each figure. So figure 1 has 5, figure 2 has 9, and figure 3 has 13 tiles. And that also is growing by 4, like tile pattern 1. So with that being the case, that means that figure 0 should have 1 tile, and figure 4 should have 17 tiles. So where do we see this growth happening? It appears as if it is happening here, where you add 1 tile to the end of each one of those arms. That's your 4 for your growth. So we started here, we add 1 to each one, and we go to the next one where we add another 1 to each one. So there's the other 4. Make it 13, so that way when we make it to the 4th figure, we will have this 1 in the middle with arms that are 4 long. So I guess you could look at it this way. You take a look at the figure number, and that's how many tiles are in each one of those 4 arms, and the 1 tile that is there from the beginning is that single one in the middle. So if we think about it this way, here's the single one in the middle, and it's always going to stay there. That's constant. That never changes, but what does change is the fact that you continue to add 4 more on each one of those arms every single time. So, oops, stop it. What is going on here? Okay. So the growth rate was +4, just like the previous problem. Where is it growing? Well, it's adding 1 tile to every arm, and since there's 4 arms, that means you're adding 4 to each figure. And that makes our rule y equals 4x plus 1, where 4 is the growth rate, big multiplied times x, and 1 is where we started with figure 0. So if you picture the 100th figure, you're still going to have that 1 in the middle, but you're going to have 400 total tiles going around it, because you have 100 in this one, 100 in this one, 100 in this one, and 100 in this one for your 401. Looking at tile pattern 3, looks like we've got 7 in figure 1, we got 11 in figure 2, and you've got 15 in figure 3. So it does have a growth rate. It's growing by 4 every single time. Now, where are the 4 that keep getting added on? Let me do this in green here. So it looks like one of them is being added on here, and then you've got 3 being added on the right-hand side. So every single time you add 4, one of them on that first column, and a column of 3 being added to the right. So if we were to continue with that pattern, this one would have to have 19, right? Because it's growing by 4. So you'd get 1 more in that left column, and then another column of 3 on the right-hand side. So here's that 1 more here, and then here are those 3 on the side. Working our way backward, we would take away this one and take away those 3. So it looks like this one should have 3, correct? And that would be the original 3. And so every one of these has the original 3. There's the original 3. There's the original 3. There's the original 3. And there is the original 3. And so depending on the figure number, that's how many 4s will be added on. So figure 4 added 16, right? these 4 and these 12 to the original 3 to give us our number. So the 100th figure should have added 100, a column of 100 here, should have 100 rows of 3 for a total of 400 plus the original 3. And so you get y equals 4x plus 3 for 403 total tiles, where the original 3, that's the constant at the end, and then it grows by 4 with every single tile figure. Now let's take a look at some questions that we had here before we got to this problem. So it says, when you compare these 3 patterns, that was A, B, and C, what is the same and what is different about each one of those patterns? So what did you notice was the same thing that happened for all of them? Notice that the figure number for figure 0 appears to be different for each one of them, right? This one started off with 2, this started off with 1, this one started off with 3, but the growth rates are the same for all of them. Every single one of them grows by 4. So that's how I would use, that's what I would say to describe the patterns. All 3 patterns have the same growth rate, but the different number of tiles for figure 0 gives it a slightly different rule. So the rules, we've already found those. The connections, we've already talked about the connections and showed them on the resource page. So this says, imagine that the next team or the team next to you created a new tile pattern that grows the same way as the one that you're working with, but they refuse to show you their tile pattern. What other information would you need to be able to predict what the 100th figure would look like and how many tiles would be in that 100th figure? Well, if they have the same growth rate, you don't have all the information. All you know is the number that's being multiplied times x. You need to know what the 0 figure would be, or the starting amount. What did you start with before you started increasing according to your growth rate? So it says here you would need to know the number of tiles in figure 0 to find the rule. Then, once you know that, then you can put that in conjunction with your growth rate to figure out what would be in the 100th figure. So let's get to pattern 4. Let's do the same process. This is a little bit different than the others. The first one, figure 1, had 5 tiles. Figure 2 had 7 tiles. Figure 3 have 9. This one is not growing by 4. This is growing by 2. And where do we see the growth of these 2? Well, it looks like it grows here and here. So here's that, the figure 1 had that cross there with 5 of them in there. Here's this cross right here, and you're putting in the 2. So the next one is going to add 2. So if I'm going to draw figure 4, which should have 11 tiles in it, I want to take all of figure 9 and add 2 more tiles down to the bottom. So this would be where we keep adding those on. So I call those legs. 1 tile is being added to each of the 2 legs. All right, so let's work our way backwards. If they're all being added here in these columns, then when you go backwards, it should be these were the ones that were added to the original 0 figure. So we should have had 3 tiles in that 0 figure, and that should be the constant column of 3. So once again, let me go ahead and highlight. This is what is constant in every single one of these tile figures. Original 3. And depending on your tile figure, figure 1 added 2 tiles. So that's 2 times x. Figure 2 is 2 times 2, so that's 4. Figure 3 is 2 times 3, and figure 4 is 2 times 4. So it looks like our growth rate in this case causes us to have a rule that says y is equal to 2x instead of 4x. But we're still going to take the 0 figure, and that's still going to be the number being added on at the end, because that's what remains constant in all of these figures. So the 100th figure will have 203 tiles on it. It'll have a column on the left that has 100 tiles, a column on the right with 100 tiles, and you'll have those original 3 that we started with for 203 tiles. So we found the equation. What's the same about this pattern in tile pattern 3? Well, the same is that they both started with 3 tiles for figure 0. But what is different is that they have different growth rates. Tile pattern 3 grew by 4 every single tile pattern, or every single figure, I should say. And tile pattern 4 only grew by 2 tiles with every figure number. So D is a really important question for us to be able to answer. The growth factor, which I refer to as a growth rate, same thing. The growth factor is the number of tiles by which the pattern increases each time you move from one figure to the next in the sequence. How is the growth factor represented in each situation? Well, let's come back and look over here. Remember, the growth factor, the growth rate was 4, and there's the growth factor being multiplied times x. Here's the 4. Here's the growth factor being multiplied times x. Here's another growth rate of 4, and here's another growth factor being multiplied times x. But in this case, the growth rate was only 2, so we're going to have a growth factor that multiplies times x in this rule of 2 times x. Okay, so your pattern of growth, your growth rate or your growth factor, that is the number that is multiplied times x in your rule. Using mathematical terms, algebraic terms, we would call it the coefficient of x. So remember the difference between a coefficient and a constant in algebra. The coefficients, goodness gracious, I guess I'll do it here. The coefficients are the numbers being multiplied times variables. Constants are the numbers themselves that are not attached to variables. So in this case, the constant, what remains constant in each one of these? The original 2. That stays the same. And every figure number, especially all the way up to the 100th figure, you'd multiply the figure number times 4 and then add the original 2. Okay? So we will continue practicing with this. If you printed this resource page off and you did all of your work on this resource page, please do not throw it away. We are going to come back to this. In fact, I think in tomorrow's lesson, we're going to reference it to create tables and graphs for each one of these tile patterns. So if you've got it in your journal, that's wonderful. That's going to stay there forever. You'll never lose it unless you lose your journal. But if you've got it on a separate piece of paper, you might want to figure out a way that you can attach it to your journal or put it in your math folder in a pocket where you know it will never get lost. Okay? All right. So great job. Less than 30 minutes. All right. Pretty good day for the lesson. Wasn't too long. Wasn't the shortest either. All right. Take care.
Hey, feeling good, like I should. When in dark, walk around the neighborhood, feeling blessed.